Hello everyone, this is Reshma from Edureka and I'm very excited to take up my first live session here on YouTube. So thank you all for joining this session on Git, and in this session we'll majorly focus on the different workflows on Git and how to handle merge conflicts when they arise. So this is the agenda for today. So we'll take a brief introduction to Git. We'll see all the Git commands that we use, the different Git workflows that different dev teams follow, and how to handle merge conflicts in each of the workflows. So this is the short agenda for today. Now let us take a brief look at what is Git and what does it actually do. So Git is a version control software that is mainly used in software development to help to manage your code better. And how exactly does it manage your code better? It helps by keeping versions of your code. So let's say that you have got your source code file and in time you'll keep making changes to it. Maybe like adding new features or doing bug fixes. And sometimes you would want to go back to the previous versions because the newly added features might not be working out the way you want to or because of any other reasons. And Git will help you to roll back because it has been keeping snapshots every time you change something. And these snapshots are known as version 1. So let's say that this is your initial code, you made some other changes in the initial code, then it'll keep a version for that. And similarly, as time passes by, it will keep different versions, and whenever you want to go back to any of the working versions, you can do that with the help of Git. So this is how Git helps in code management. So now let us take a look at the Git basic commands. So if you want to create repositories, let's say you want to create your local repository, you just have to initialize it using git init. Or if there is an existing repository, you can use git clone. If you want to make changes in your file, you can use different commands. You can use git status to see whether a file is there in your index or not. You can use git add in order to add a file on your index, and you can finally use git commit in order to commit those changes that you have made. For syncing in repositories, so you know that in Git we deal with two repositories, the central and a local. So you have to inform your local repository that which is your central repository that basically lies on a remote machine. So for that we add origin. We add the link of the central repository using this command git remote add origin. And then if you want to pull all the files that are in the existing central repository, you use a git pull. And then finally, if you want to reflect your changes into the central repository, you can use git push. For parallel development, we have got git branch. It allows you to branch off from your main branch and you can work on different features on a completely isolated branch using git branch. And then you can finally also merge all those changes in your production deployable branch, which is usually the master branch, using git merge. And then we can also use git rebase. Now this is a special kind of merge. So it basically does the same thing as git merge, only the commit workflow or the commit working tree looks a little bit different. So you'll know about that because we'll be using rebase in today's session. So now let us take a look at the Git workflows. So basically the Git workflows can be categorized into broadly three kinds. So there is the centralized workflow where there is one central repository and only one working branch, which is the master branch. Then there is the feature branch workflow where you have dedicated branches for each feature, and then you've got Git flow. So we'll take a look at all of this and how to solve conflicts in each of these workflows. So now let us talk about the centralized workflow. So the centralized workflow uses a central repository to serve as a single point of entry for all changes to the project. And there is only one default development branch, and it is called the master, and all changes are committed into this branch. So this workflow does not require any branches besides the master. So what the developers do, they start by cloning the central repository into their local repository. And in their own local copies of the project, they will edit the files, commit changes, but you should know that these commits are stored locally. They're completely isolated from the central repository, and if the developers want the changes in the central repository, they'll have to git push it. So now let's say that we have got three people. We have got Bob, Alice, and Jake, and they are working on a project X. So now let's say that Bob here makes the changes in the project, commits it, and then pushes it into the central repository. So his changes will be published into the repository with his recent commits. And now let's say that Alice is also working on the same thing and she wants to publish her changes in the central repository. But since Bob and Alice changed the same file in the same line, there will be a conflict. So let me show you how exactly does it happen and how to solve it. So here I have created repositories for Bob and Alice. So they are just in my system at different folders. So since I have to show you this scenario, I have to pretend to be two persons at one time. So what I'll do, I'll just click Git Bash here. Now I'm using Git for Windows, so you just don't have to do anything. You just click Git Bash here and it will open up the Git Bash shell. And the same thing I'm going to do for Alice over here. So let me just adjust the screens so that you can see what I'm doing in both of this Git Bash shells. So I hope that you can see the screen over here. So this is Bob's local repository shell that we're using, and this is for Alice. So the first thing that you need to do, you need to initialize your repository. So for that, you have to use git init. And I'll do the same thing for Alice. It's done, and now what I'm going to do, I have already set up my central repository on GitHub. So I'll just add the origin using git remote add origin. So I'll do that for Bob. I'll use this command, git remote add origin. And now you need to provide the link of your central repository that is on GitHub. So I'll just go to my GitHub. So you can find the link over here. So you just copy it, paste it, and I'll do the same thing again for Alice. Alright, so now there are files that are existing in my central repository already, so I want to pull those files. So for that, I'll just use this command, git pull origin master. So it has pulled all those files. I'll do the same thing for Alice again. So now if you see their repository, so this is Bob's repository, it has pulled all the files from my central repository, and this is the .git hidden folder. This gets created when you initialize your repository, specifically when we typed git init. Alright? So now let us assume that Bob has made some changes. So let's say this file over here. So I'm just taking very simple examples. So basically there will be code here, just so that you can just understand the concepts of conflict. I'm just using simple text files. So let's say that Bob has made some change like this. Saved it. And now Bob wants to commit this changes. So first Bob will check the git status to see, So git status will show you whether a file has been added to the index or not. So if it is in red, it means that it has not been added to the index. So for that, we'll have to add this file. So we'll use the command git add and the name of our file. So now if you check git status, so you can see that it is green now, so it means that it has been added to the index. It is there in the staging area and it is ready to be committed. So now we'll use git commit in order to commit this. And also remember that we have to commit using a message. So I'll just pass this Bob changing Edureka. So it is committed. Now Bob wants to push it to the central repository. So I'll use git push origin master. And it's done. So if you go to your central repository now, so let me refresh this page. So you can see Bob's commit over here. So that means that this file has been changed in the central repository. So now let us go to Alice's local repository. And let's say that Alice does not know that Bob has already made changes in the central repository and she's doing her work in her own local repository and she has changed the file something like this. So we'll close it. Now Alice will also do the same thing. She will add the file and then she will commit the file. You have to pass this flag M. So let me just keep it simple. I'll just write Alice over here. And now she would want to push it the same way that Bob has done, git push origin master. And since it's a centralized workflow, there's only the master branch. So you can see that there is an error that has been rejected. The updates were rejected because the remote contains work that you do not have locally. So it means that something was changed in the central repository, which Alice's local repository doesn't contain. And now it is centralized workflow. And I don't want to mess around with my master branch because my master branch is supposed to always be, and my master branch is always supposed to keep the production deployable code. So instead of just pulling it directly, I'll use rebase. So what rebase will do is that it will always have the initial commits that will come from the central repository. It will just add up my commits on top of that workflow or my working tree that shows all my commits. So I'll show how it works. So for that, I'll not just pull it directly. I'll use a different command, git pull rebase origin master. So it is showing that there is a conflict in the content and it is in edureka.txt. And even this message doesn't appear and you're confused where the conflict is, you can do one thing. Let me first clear the screen. You can use git status to see where the conflicting file is. So you can see that edureka.txt. So in order to solve this conflict, I'll use git merge tool. So you can see it has opened up 3 files. So this is the file that Bob has changed. This is what was the original file, and this is what Alice have changed, right? So Alice can take a look, and this is the head where her initial commit right now points to. So she can decide whether to keep the changes or not. And let's say that Alice wants to edit it. She wants to solve the conflict. And let's say that she decides that she wants to keep both the 2 lines. So let's remove all that. Save that file. Again, save and exit. Save and exit, save and exit. All right, so now you can continue rebasing. So for that, you can use this command. Okay, let me clear my screen so that you can see what I'm typing. So you can use this command, git rebase continue. So it has applied my last commit that I was trying to push it onto my central repository. So now the merge conflict is solved, and I should be, or let's say Alice should be successfully be able to push it to the central repository. So let's try it. And the conflict is solved and it is successfully pushed onto the central repository. So let me just show it to you. So here is Alice's commit. So this is how you deal with conflicts when you are using a centralized workflow. So I hope that this is clear. So now let us talk about the feature branch workflow. So if your team is comfortable with the centralized workflow, but they want to streamline its collaboration efforts, and it is definitely worth exploring the benefits of the feature branch workflow. So what happens here is that you dedicate an isolated branch to each feature, and because of this, it is possible to initiate in-depth discussions around the new additions before you try to integrate them into the official project. So the core idea behind this feature branch workflow is that all feature development should take place in a dedicated branch instead of the master branch. And this encapsulation actually makes it easier for multiple developers to work on a particular feature without disturbing the main code base. Because again, I'm telling you, the master branch should always contain production deployable code. So it also means that the master branch will never contain broken code, and this is going to be a huge advantage when you're dealing with continuous integration environments. So again, let us consider the scenario. So this is a feature branch workflow. So they're all working on the features. So let's say that Jake here is working on feature B, and Alice and Bob are again working on feature A. So again, first Bob makes a new branch, and he pushes that new branch where he has added some features, and he has pushed it into the central repository. And then again, Alice wants to push it again. The same things that she might have, some changes that she might have done in the central repository. So then there is an advantage of using the pull request. So pull requests are a way to initiate discussions around a branch. So they give other developers the opportunity to sign off on a feature branch before it's get integrated into the official project. So let me just show you an example of this again. So open up this repositories again. So this is Bob's repository. So let's say that Bob wants to now branch off and work on his new feature. So he just can use this command over here, git branch, and let's say his feature is called feature 1. So now let's check out the feature 1. So now Bob is in the feature 1 branch. So let's say he wants to add something. All right, so just save and exit. And now again, Bob wants to add this file. All right. He will commit this file. Commit done. Just clear it for you. And now you would want to push this branch onto the central repository. So for that, he'll just use the same command, git push origin and the name of his branch. And this will actually create a different branch in the central repository with the same name, and it will serve as a remote tracking branch. And it is done. So if you go to the central repository, now you can see that less than a minute ago there was a new branch here which is called the feature 1. So if you go check out this branch in GitHub, you can see it has got this file along with the other files because it was actually branched off from the master with the latest commit where it contained all the files, right? So now if Bob wants Alice to know that he has made some changes because now they're working in a featured branch workflow, so he will file a pull request. So how to do that in GitHub? You just have to go here. Just click this button, new pull request. The base should be master branch and compare the feature 1. And then you can add some comments over here, so you can just create and just let's say that please check it out. So if you want reviews on your branch, whether you have done or developed the feature in the correct way or not, you can actually add reviewers here, and you can actually also assign someone here. So now since my GitHub only have me as a collaborator, I don't have anyone else, so you can add other people who are actually contributing onto this central repository. And then finally you can click this button. Oops. Alright, there seems to be some internet issues with GitHub. Alright, but the good part is that I'm actually done with that. You don't have to do anything after you have created that pull request. So what will happen after that is that whoever you add as a reviewer, so they will either get a mail of how you set it up, so they'll get a mail, and then you can also comment, and there will be a back and forth discussion about what to change or not, and finally you have to merge it when it has been set. So when you're when your entire team is satisfied on the feature that you have worked on, so someone will finally merge it onto the master branch. So this was all about the feature branch. So pull requests come in handy when you want to carry out discussions with your entire team. So now let us talk about Git flow. So Git flow workflow defines a strict branching model that is designed around the project release. So this is somewhat more complicated than feature branch workflow, but this provides a robust framework for managing larger projects. So this is what the entire branching model kind of looks like. So you don't have to worry, even though it looks very complex, this workflow does not add any new concepts or commands beyond what's required for the feature branch workflow. Instead, the difference is that it assigns very specific roles to different branches and defines how and when they should interact. So in addition to feature branches, it uses individual branches for preparing, maintaining, and recording releases. And of course, you also get to leverage all the benefits of feature branch workflow, the pull requests, the isolated experiments that you do on your feature branches, and more efficient collaboration. So how does it work? So the Git flow workflow uses a central repository as a communication hub for all developers, just like all other workflows. And the developers, again, work locally and push branches onto the central repository. So the only difference is the branch structure of the project. So instead of a single master branch, so this workflow uses two branches to record the history of the project. So the master branch here actually stores the official release history, and then develop branch that serves as an integration branch for features. And it is very convenient to tag all the commits in the master branch as different versions. So here you have tagged it as version 1.0, 1.0.1, then 1.1.0, something like this. So whatever naming scheme that you are comfortable with. So you have got feature branches. So there are two feature branches mostly. So one is there which majorly focus on the coming release, and the other needs to be worked on for a coming release or a future release. So when a feature is complete, it gets merged back to the develop branch, and feature branch should never interact directly with the master. So feature branches combined with develop branch for all intended purposes to the feature branch workflow, but the Git workflow does not just stop there. So once develop has acquired enough features for a release, or let's say a release date is coming up, so what do? You fork a release branch off to develop. And creating this branch starts the next release cycle, so no new features can be added at this point, so you can only do bug fixes, some hot fixes, some patching up things. And once it is ready to ship, the release gets merged onto the master and tagged with the version number. So this is how Git flow works. So obviously you'll also find merge conflicts here, but it is very easy to fix because it is more in a structured way, and when you have a lot of people working on a particular application, especially larger applications, you can use Git flow for that, and in most of the companies people use Git flow. So all you have to do, you have to create feature branches, you have to create a develop branch, and you have to follow the Git flow. So just flow with the Git flow. And so here are the different workflows. I hope that you have understood something, you have learned something new, and I have shown you in a very bare minimum ways just so that you can get the concepts. So, all right, so if you have any questions, you can leave it on the comment section below. And I'm very glad to announce that Edureka has finally launched their DevOps Engineer Master Program. And Edureka has tailor-made this particular course for you to become a DevOps expert. So it includes each and everything that you need to learn, starting from the basic to advanced, covering every concept that you need to know. So here's everything that you will learn. So these are some must-have things that you should go through in order to become a DevOps expert. So you'll be learning Linux fundamentals, Python, DevOps, Docker, AWS, Splunk. And here are some free electives that you can choose. So you can choose either a self-paced course on Jenkins, Puppet, Chef, Ansible, and even Git. So you can check out our course landing page at www.edureka.co, and you can just type in DevOps Masters Program, and you can check out all the things. So you have got everything mentioned here, and the earliest batch that starts, the orientation class, starts from 21st August. So make sure that you attend it. So thank you so much for attending this session. I hope that you liked it, and I'll see you next time. Till then, happy learning.